mathematics class. This class is for class 9 in continuation to the previous class of midpoint theorem. In the previous class we have discussed up to question number 10. Question number 9. Now we'll start with question number 10. What is question number 10? It has three parts. So first part we have taken. They say in a quadrilateral given, this is a quadrilateral A, B, C, D. In this, what is given? That AB and CD are parallel. Given AB parallel to CD, E and F are the midpoints. E and F are the midpoints of AD and BD. We have to prove that G is the midpoint of BC. We have to prove that G is the midpoint of BC. And second part, we have to prove that EG is equal to half of AB plus CD. So first we'll start with first part. What we can see, if we consider triangle DAB, we can say in triangle DAB, what is given? It is given that E is the midpoint of DA and F is the midpoint of DB. At the same time, it is okay. So we can say that E and F are midpoints of AD and BD. This is given. This is given. If these are the midpoints, so according to midpoint theorem, we know that a line joining midpoints of two sides of a triangle is parallel to the third side and equal to the half of the third side. So we can say that EF is parallel to AB, and we can also say that EF is half of AB by midpoint theorem. Now this we have it is given, so we have proved that this EF is parallel to AB. Second, what we can do now, if we consider triangle DBC, in triangle DBC, we know that F is the midpoint of DB, and since we have proved that EF is parallel to AB, it means that EG is also parallel to AB. Why? Because EG is in continuation to EF, and we have proved that EF is parallel to AB. So if I say EF is parallel to AB, implies that EG is parallel to AB, and this implies that if we say EG or we say FG, so we can say that FG is parallel to AB, and this is what we required in the second triangle. Now if we consider triangle DBC, we can say that F is the midpoint of one side and this FG is parallel to the third side. Why it is? We can say that FG is parallel to CD. Why? Because AB and CD are parallel, and that is given. If AB is parallel to CD and FG is parallel to AB, means AB is parallel to CD, and it is given that FG is parallel to AB, it implies that FG is also parallel to CD. So this is what we require. Now next part, we have proved that FG is parallel to CD. Now if we consider triangle DBC, in triangle DBC, we can say F is midpoint of BD and FG is parallel to CD. So we can say that therefore G is midpoint of BC. Why? Converse of midpoint theorem. What is the converse? That if a line is parallel to one side of a triangle and it passes through the midpoint of the other side, then it also passes to the midpoint of the third side. So this we have proved that G is the midpoint of BC. First part has been proved. Now we move on to the second part. In the second part we have to prove that EG is equal to half of AB plus CD. Now EG can be broken into two parts. EF, we can say that EG can be written as EF plus FG. We know that EF is parallel to AB. Here we have proved that EF is parallel to AB and half of AB. So in place of EF we can write AB upon 2 plus, now FG, since F and G are the midpoint, they have been proved in the previous part that G is the midpoint of BC and F is the midpoint of DB, that is given. So F and G are midpoints of DB and CB, therefore FG is parallel to DC and half of DC. So in place of FG we can write DC upon 2. I am writing here because F and G are midpoints of BD and BC. Therefore FG is parallel to CD and FD is equal to half of CD. By what? By what theorem? By midpoint theorem. So AB upon FG is AB of FG is CD upon 2 and EF is AB upon 2. We take 1 upon 2 common. We are left with AB plus CD and that was your EG. That is the proof. Hence proof. Now we move on to the second part of this 10th question. Now in the 10th question second part, it is given that ABCD is a quadrilateral. In this quadrilateral, AB is parallel to CD is parallel to EG. Means AB, CD, EG, all these three lines are parallel to each other, and what is given? E is the midpoint of AD. This E is given midpoint of AD. First thing we have to prove, G is the midpoint of BC. We have to prove G is the midpoint of BC. This is just like first part. What we can say again in the first part, which triangle we are going to take? DAB. So we'll say in triangle DAB. In triangle DAB, it is given that E is the midpoint of AD and EF or EG. If EG is parallel to EB, it means EF is parallel to AB. So if according to the converse, if one midpoint is given and a line parallel is given, then it means that F is also the midpoint of DB, that is the third side of the triangle. So we can say first point is E is midpoint of AD. This is given. Second point, we can say that EF is parallel to AB. Why? Since EG is parallel to AB and that is also given. So we can say that F is midpoint of DB. By what reason? By converse of midpoint theorem. By converse of midpoint theorem, we have proved that F is the midpoint of DB. Now what we will do, we will consider triangle, the other triangle DBC. In triangle DBC, again we can say that F is midpoint of DB, proved above. This we have just proved above. And second point, we can say that EG is parallel to CD. Why? Since it is given that EF is parallel to CD. Given. You can say given. It is given that EG and CD are parallel, and if EG is parallel to CD, it means part of EG, that is FG, is also parallel to CD. So because of this, we can say that G is midpoint of BC by converse of midpoint theorem. This one part has been proved that G is the midpoint of BC. Now we will talk about the second point. Second point, you have to prove that 2 times of EG is equal to AB plus CD. Same as we have done in the A part, everything is same. We know that EF is parallel to AB, so we can say EF will be half of AB according to midpoint theorem. So first of all, EG can be written as EF plus FG. EF can be written as half of AB and FG can be written as half of CD. Now when you take 1 upon 2 common, you are left with AB plus CD is equal to EG. Now cross multiply 2 comes to this side, so 2 times of EG is equal to AB plus CD, and that is your proof. This was the second part. Now we move on to the third part or C part of question number 10. Now third part is based on first 2 parts. If you have understood the first 2 parts, you can easily find the value of what is required. Now I will read out the question. It is given a quadrilateral ABCD in which AB and CD are parallel. So it is written AB and CD are parallel. E and F are the midpoints of AD and BC. E is the midpoint of AD and F is the midpoint of BC. You have to find EF. This total length you have to find. When AB is 6 centimeters, this is given 6 centimeters and DC is 4 centimeters. In the previous questions you have seen that EF was, we have already proved that EF was half of AB plus CD. So simply you can place the value. AB is 6, CD is 4, 6, 4, 10 and 10 upon 2, that is 5 centimeter. Now if the question comes in the exam, then you have to prove this. How are you going to prove this? That we have done in A part and B part. You will join this BD. Let the point be M over here where EF is intersecting. Now you will prove that since E is the midpoint of AD and EM is parallel to AB. EM is parallel to AB. So M will be the midpoint of DB. Similarly, MF is parallel to this, and that way you can. Now the question is, how will you prove that the point M is the midpoint? Because it is only given that E is the midpoint of AD and it is not given that EF is parallel to AB or EF is parallel to CD. But according to the intercept theorem, you have learnt that if there are parallel lines, 3 or more parallel lines, and they make equal intercepts, so you can see that this point, this ED and EA are equal at the same time, FC and FB are equal. It means that AB is parallel to CD is parallel to EF. In the diagram it shows that AE and ED are equal. They say that E and F are the midpoints. So E is the midpoint, it means these 2 parts are equal. F is the midpoint, it means these 2 parts are equal. Now you can see 1, 2, 3 lines. There are 3 lines out of which 2 transversals are intersecting and their segments are equal. This is equal to this, at the same time this is equal to this. It means that three lines are parallel. When these three lines are parallel, then EM will be half of AB and MF will be half of CD. We can say that EM will be half of AB and we can say that MF is equal to half of CD. Now when you add EM plus MF, you will take 1 upon 2 common, AB plus CD, and EM plus MF is EF is equal to half of AB plus CD, and now we have substituted the value, so it is 5 centimeters. Now we move on to the second part. The second part says find AB. We have to find AB. If BC is equal to 8 centimeters and EF is equal to 9 centimeters. Again the concept will be same here. They say BC is 8 centimeters and EF total is 9 centimeters. This total is 9 centimeters. We have to find the value of AB. Now we know that MF is half of BC, so MF will become 4 centimeters. This total is 9 minus 4, this becomes 5 centimeters, and this 5 will be half of AB, so AB will be double of 5, it means 10 centimeters the final value. So what we can say, first we can say MF will be half of BC, that is 8 upon 2, that is 4 centimeters. Now EF is given as 9 centimeter. EF can be written as EM plus MF is equal to 9. MF is how much? 4 is equal to 9, implies that EM is equal to 9 minus 4, that is 5 centimeter. So EM came out to be 5. We know that EM is equal to half of AB, implies that EM was 5 is equal to AB upon 2, cross multiply, so AB is equal to 10 centimeter. So this is the final value. Now we move on to the next question. Now question number 11, first part. It is given that in the quadrilateral AD is equal to BC, length of AD and BC are equal. Second point, they say that PQRS are the midpoints of AB. P is the midpoint of AB. Q is the midpoint of BD. BD, CD, AC, CD and AC. Okay. AC. Now what is given that P is the midpoint of AB, Q is the midpoint of BD, R is the midpoint of CD and S is the midpoint of AC. We have to prove that PQRS is a rhombus. So first of all we will prove that PQRS is a parallelogram, and if in a parallelogram two adjacent sides are equal, then it is a rhombus. What is a rhombus? I'll write the definition. Rhombus is a parallelogram with adjacent sides equal. So first of all we will prove that PQRS is a rhombus, then we will prove that the parallelogram PQRS, its adjacent sides are equal. Now how to prove that PQRS is a parallelogram? If we consider the triangle CDA, proof, I am writing the proof. What is the proof? First point we'll write, in triangle CDA, CDA. What you can see, R is the midpoint of this of CD and S is the midpoint of CA. So RS will be parallel to AD and half of AD. So we can say that RS is parallel to AD, and we can say RS is equal to AD by 2. Why? By midpoint theorem. By midpoint theorem. If you want, you can write the reason that R is the midpoint of CD and S is the midpoint of AC. So by midpoint theorem, these will be equal. RS will be parallel to AD and RS will be AD by 2. Now second thing, we can prove if we take triangle DBA. Now we'll take in triangle DBA. DBA. Q is the midpoint of BD and P is the midpoint of AB. So this PQ will be parallel to AD and half of AD. So again we can say that QP is parallel to AD and QP is half of AD. Reason is again midpoint theorem. Now in quadrilateral PQRS, we have proved that, let us say that this is equation number 1. Let us say that this is equation number 2. We have proved that SR is half of AD and parallel to AD, and at the same time PQ is parallel to AD and half of AD. So RS is also AD by 2, QP is also AD by 2. RS is also parallel to AD, QP is also parallel to AD. It means we can say from 1 and 2, what do we get? From equation 1 and 2, we can say that RS is parallel to QP and RS is equal to QP. Why? RS was parallel to AD, QP is parallel to AD. So RS is parallel, if I say A is parallel to B and C is parallel to B, implies that A is parallel to C. So similarly RS is parallel to AD and QP is parallel to AD. So we can make out that RS and QP are parallel. So that is the result. Similarly RS is equal to half of AD, QP is half of AD. So RS and QP will be equal. So this is equal. Now we can see that RS, this side RS, and QP, this side, are the two opposite sides of a quadrant. So we can say that PQRS is a parallelogram. Why it is a parallelogram? Because opposite sides of parallelogram are parallel and equal, and that is what we have proved. We have proved that this side and this side is parallel, and the same these two sides are equal to each other. So it means these two sides are parallel and equal, and in a parallelogram, if a pair of two sides is parallel and equal, then that quadrilateral is said to be a parallelogram. So we have proved that PQRS is a parallelogram. Now we have to prove that PQRS is a rhombus. So how can we prove that? It has been given to us. We have already proved that. Okay, in that we will take one more. Now we take in triangle CDB. CDB. Now in triangle CDB, R is the midpoint of DC and Q is the midpoint of DB. So we can say that RQ is parallel to BC, and we can say that RQ is half of BC. Reason again midpoint theorem, because we know that in a triangle, if a line joins midpoints of two sides of a triangle, it is parallel to the third side and equal to half of it. That is the midpoint theorem. So we have proved that RQ is parallel to BC and RQ is half of BC. what we need is this part. We know that RQ is equal to half of BC, and it has been given that AD and BC are equal. It means in place of BC we can say AD upon 2. In place of BC, because BC and AD are equal, so BC can be substituted by AD. So in place of BC we substituted AD, so AD upon 2. Now AD upon 2 is your RS side. We have written RS is equal to AD upon 2. So in place of AD upon 2 we can say RS, implies that RQ is equal to RS. This RQ is equal to RS. Now this RQ and RS are the adjacent sides of parallelogram PQRS. Now these we have proved that RQ and RS, these are the adjacent sides of the parallelogram. Now when the adjacent sides of the parallelogram are equal, then we can say that PQRS is a rhombus. So I have finished with 11th question first part. Now maybe 1 or 2 questions are still left, that will be considered in the next class, and after that one more chapter is there, that is Pythagoras theorem, and I hope your half yearly syllabus will be over, because in half yearly I think up to chapter number 12 is there, that is Pythagoras theorem. So by the time, keep on studying and stay at home, and please do ask your doubts in case you have. Otherwise you can send me the problem on this, as and when I will be giving you the solution of that. Thank you all of you. Stay blessed.